Welcome to Ask and Learn.
So in this question, we're supposed to use molecular orbital theory to predict the bond energies and lengths of F2 and F2+. So I went ahead and drew out the atomic orbitals for fluorine, and then we can fill in the molecular orbital for F2. So based on that theory, we have to fill up the lowest orbitals first. And that would be our fluorine molecule. So calculating the bond energies and bond lengths, we can do that by going off usually bond order. I feel like that's probably the easiest way to do it. So bond order is going to be the number of electrons in a bonding orbital minus the number of electrons in anti-bonding orbital. And then we're going to divide that by 2. So these would be our electrons in our bonding orbitals, and the other ones would be our electrons in our non-bonding orbitals. So that would be 8 minus 6 equals 2 for F2, so that would be 1. And then we can go ahead and just edit this diagram a little bit and do F2+. So the plus signifies we lost an electron, so we can just take an electron off here. Oops, not both of them. There we go. And then from there, we can also take an electron off here. And that's taking one out of an anti-bonding orbital. So for F2+, we would have 1.5 as our bonding order. And then from here, we can see that F2 has a lower bond order, a smaller bond order, so it's going to have a smaller bond energy, and that's going to lead to a longer bond length. So we can think bond energy is going to be lower, and bond length is going to be higher. And comparatively, this one has a higher bond order, so the energy will be higher, which makes the bond shorter. Thank you.